Okay, so the last 5 pages of chapter 8 are on empirical formula versus the chemical or molecular formula. And so let's take a look one more time. The easiest questions on the test would be something like this. Which of the following, what if I showed you these right here? Which of the following are empirical formulas? You say, what do you mean? How am I supposed to know which ones are empirical? And what do you look for? What do you look for to see if it's an empirical formula? What do you think? Julie, you haven't said anything today. How would I know which of these are empirical?
It's like whichever ones can be reduced.
Right. If they can be reduced, they're not empirical. Everybody get that? So is this an empirical formula? No. It can be reduced to what? It can be reduced to CH2O if I divide everything by 6, right? Is this an empirical formula, C2H2? No, it can be reduced to CH. Isn't that right? Is this an empirical formula? It is, because you can't reduce it. It's just the empirical form is the same as the chemical, isn't it? And what about this guy? Can you reduce this? Can you divide both those numbers by the same number, not counting one, of course? No. So water is actually, H2O is not only the empirical formula, it's also the formula of the chemical. How about this one, C3H6O3? Is that empirical? No, you can divide everything by 3 and you get CH2O. See that? Now, what we started yesterday, and I'm going to finish that today, is when people have done lab tests and they say, hey, what is this stuff made of? They have all kinds of tricks in the chemistry lab to try to figure it out. But it involves mathematics. It involves mole concept too. And so what happened is, I want you to pretend that you've already done part of the analysis and you found out that the empirical formula was CH2O. Now, then you take that same chemical and do another test and find out that the molar mass is 180. Now, stay with me. The empirical is this, but the real chemical weighs 180. Is this the real chemical? And you say, how am I supposed to know? Well, how much does this weigh? Kyle, how much? Put your head up, please. How much does the CH2O weigh? Look on your periodic table. How much would CH2O weigh? And by the way, we've got to be way faster than this, okay? How many times have we looked on the periodic table and found carbon was 12? Is that right? How many times have we done that? Carbon's 12, isn't it? So here's 12. Hydrogen's 1. I have 2 of them. That's 2. And oxygen's 16. We've done this many times. 30. So now, the question is, the empirical formula weighs 30. But the real chemical weighs 180. Is this the real chemical? No. But what if you took 180 and divided by 30? How many times could I multiply the empirical formula to get 180? So 180 divided by 3 is 6. So what do I do the empirical formula? I multiply everything times 6, and it gives me C6H12O6. Let's try another one. Here's the empirical formula, CH. But another test told me that the molar mass was 26. Is this the real chemical? Is CH the real chemical? Oh, wait, let's look at it. How much would this weigh? Delaney, I haven't called you. How much would CH weigh?
13.
Yes. But the real chemical weighs 26. That can't be it. So how many times will 13 go into 26? 2. So what's the final answer? What's the final chemical? Multiply everything here times 2. I need not 1 carbon, I need 2. C2H2. Everybody got that? Let's do the next one. The next one, the empirical form is NaCl, and the real one weighs 58.5. Is this is the empirical also the real chemical? How much does this weigh? 23 plus 35.5. This weighs 58.5. The real one weighs 58.5. That's it. That is the chemical. Next one, H2O, the molar mass, another test was done and said the molar mass of the real chemical was 18. Okay, how much does this weigh? Sierra, what do you think? How much does this weigh? H2O. Each hydrogen's 1. I have 2 of them. That's 2. Oxygen 16. How much does it weigh? Okay, so the empirical formula weighs 18. The other test said that the real chemical weighs 18. You must be it. You must also be the real chemical, right? And the last one is, this is my empirical formula, but another test told me that the real chemical had a molar mass of 90. Is this the real chemical? Who have not called on yet? May, help me out. Is the real chemical this one? The molar mass has to be 90. Does this add up to 90? How much does that add up to? 30, you're right. So that means how many times will 30 go into 90? So then, take everything here, multiply by 3, and what do you get as your final answer?
6, 3, 8, 6.
And multiply everything times 3. This is actually C1, isn't it? Isn't that C1?
Yeah, so it's 3, and then 6 times 2, or 2 times 3 is 6, and 3 times 4.
Okay. So I want to get that out of the way. That's the last 2 pages of the last 5, and that's the easy thing. If you get the empirical formula and I tell you the molar mass, you can tell whether or not it's a real chemical or whether you need to multiply it by something or not. Okay, so then we did this problem on page 223. I'm not going to do it again. Let's show you again. But what happened is the easiest kind of empirical formula to get is if they give you grams. We had this many grams of aluminum and this many grams of oxygen. Now, I gave you a little conceptual idea. Ready? What world are you in if you see a formula? If you see any kind of formula, do you think you're in the mass world or the world of number of particles? What does H2O mean? Does it mean 2 grams of H and 1 gram of O? Is that what it means? No, it's never meant that. It meant, if in the little world, it meant 2 atoms of hydrogen and 1 atom of oxygen, right? Yes? Well, what about in the big world? H2O can mean 1 water molecule, can also mean 1 mole of water molecules. Now, if you have a mole of water molecules, that's a lot of them, isn't it? Then you have 2 moles of hydrogen atoms and 1 mole of oxygen. But even if, I don't care which world they're in, it's still the number of particles. Moles are number of particles, aren't they? It's not mass. Mole is number of particles. Okay, so here's my clue. If they're going to give me a problem and they're going to tell me how many grams of aluminum combined with how many grams of oxygen, okay, let's say we found this chemical and we broke it apart. We found this many grams of aluminum, this many grams of oxygen. If we found that, what's the formula? What's the empirical formula? And you say to yourself, I got to get out of the gram world. Well, what world do you want to get into? And what the world means number of particles? Moles. All right, and we just got to do it all, didn't we? So we change grams into moles, and we get a number like that. And we change grams into moles of oxygen, we get it like that. And wow, you know what? When I was your age, when I got this far, I didn't know what to do. I didn't know what to do next. Jason.
So we don't use scientific notation?
One more time.
We don't use scientific notation for that?
We don't use what?
Like in the calculator, is it not on the scientific?
Oh, you mean when I do this, divide by that?
Yeah.
I would get 3 sig figs. Now, go ahead. I didn't hear everything you said.
Like, do we not go?
Oh, I wouldn't use scientific notation here. I like to use scientific notation when you're talking about really big numbers or something like that. I probably wouldn't use scientific notation when I'm doing empirical formula. Hey, you know what? Thanks for bringing that up. I probably wouldn't use scientific notation when I'm doing empirical formula, okay? Now, this is where I would have gotten stuck if I were you. I have this ugly looking number. How many moles of aluminum do you have? Oh, 0.154. Well, how many moles of oxygen do you have? 0.231. Well, that's stupid. What does that mean? I thought you told me the empirical formula was the lowest whole number ratio. These are not whole numbers. And so I showed you a math trick. All mathematicians know this. Ready? How do you take 2 numbers or 3 or 10 and turn them into whole number ratios? How do you do that? You take the smaller of the 2. Which one's smaller? this one, and divide both of them by the smaller. Okay, what's this divided by that? What's this divided by that? And this one comes out to be 1. This one comes out to be 1.5. Now, at least they're not as ugly looking. Are we getting closer to whole numbers? Now I have to do one more thing. This is not a whole number, but what's 1.5? How do I turn it into a whole number? Multiply it by 2, right? 1.5 times 2 is 3, isn't that right? $1.50 and $1.50, isn't that $3? Okay. So, but if I multiply this number times 2, I have to multiply this times 2, and now I have 2 to 3, and now I'm done. I know my analysis showed that this chemical, for every 2 moles of aluminum, it'll combine with 3 moles of oxygen. And that's how they did it. Now I'm going to step it up a little bit. The next problem is a little more difficult, okay? And I want you to be able to do this because I know you guys can do it. As a matter of fact, some of you on the math part, you seem to be doing quite well. All right. Let's go to this page here. Now, if you don't have your book, I'm going to magnify this so you can read it. All right. Can everybody see that problem here? Now, it's on page, if you want to write in your notes, it's page 224. Here's the question. When a 0.3546 gram of vanadium, sample of vanadium metal, they're going to heat it. And when heat it, it combines with oxygen and it forms a new compound. Now, nobody in here, I didn't ask you to do that in our last lab. Can I ask you something? What do you think would have happened when you took that piece of copper? What if you would have weighed that piece of copper real carefully? Okay? And then you put it in the flame, and you know what was formed on that copper? What was formed on the outside of the copper? Thanks. What was formed on the outside of the copper? That was the lab. That was in a lab test and everything. All right, raise your hand if you know. Well, if I would have weighed that piece of copper and written it down, and then I took the copper and heated it, what happened to that piece of copper when I put it in the flame? It reacted with what? Right, and didn't it make some other funny looking chemical, like a blackish stuff on the outside? Now, can I ask you this question? If you had copper atoms and they had a certain weight, and they grabbed a hold of oxygen and made this thing called, remember, copper 2 oxide? Would it weigh more or less? It'd weigh more. Now, look at the problem here. How much vanadium do you have? Do you have how many grams? I got grams of vanadium. But then it says when you heated it, they weighed it again, it weighed more. Why did it weigh more? I really need your attention. I mean, this is something, I know you can do it. I wouldn't even teach it if I didn't think you could do it. Why does it weigh more? Yes? It did. Now, do you know how many grams of oxygen it combined with? And don't tell me you can't. I know you can think. I know you can think. How many grams of oxygen? So, what we have to do is, ready? This second number is vanadium and oxygen combined, isn't it? That's vanadium and oxygen. What's the first number? What's the first number? Just vanadium. What do you think vanadium and oxygen minus vanadium gives you? Oxygen. So, everybody do that, okay? I want you to tell me how many grams of oxygen are in this compound, and if you want to write in the book, you can. How many grams of oxygen are in this compound? And the compound's right down here. Right there, see that? How many grams of oxygen are in that? and again, I'm going to mention to you, you're in 10th grade, and you're in chemistry class, right? You have to say to yourself, I should be able to do this. If that's vanadium and oxygen combined, and that's vanadium by itself, then how would I find just the oxygen? Would I add, subtract, multiply, or divide? Subtract. Right? All right, what do you got? Did everybody have it? All right. Did you get something like this? Did you get something like that? Okay, now, does this problem look different to you than the first one we did? Well, yeah, it looks different. But now what? Now what? Do I have grams of vanadium now? Yes. Do I have grams of oxygen? Yes. Now doesn't it make just like the one we just did? All right, I want you to find a partner. I want you to say, and here's what you're going to do. You're going to start, and you're going to say, this many grams of vanadium, this many grams of oxygen, factor label, do it, and then find how many moles. Find how many moles. Sit with somebody. I want you to do this problem. You're going to find out how many moles. Now I'm going to do the problem up here, and we'll see how well you did. Okay, yeah, gotcha.
Since I wasn't in class yesterday, I was taking a test. Would I take?
Okay. So the tricky part of this question is, do you understand how many grams of vanadium they started with? That's the easy thing. So that's how many grams of vanadium right here. They didn't tell you, okay? But this is not vanadium. This is after they heated it. And what happened to the vanadium? Watch. It grabbed a hold of some oxygen. It became heavier, didn't it? So the second number is vanadium and oxygen. So what if you had the number for vanadium and oxygen combined, and you subtracted the grams of vanadium? What would that give you?
27.
Grams of what?
Oxygen.
Of oxygen. So that's what I'm doing here. So here, this is how many grams of vanadium and oxygen combined. Then this, they told me this is how many grams were just vanadium. When I subtract, I'll get this many grams of oxygen. So now watch this now. Now the problem turns in just like it was before. The one we just got done, grams of vanadium, and we're going to change that to moles. And then go down here, we're going to do 0.2784 grams of oxygen, and we're going to change that to moles. Now, let's see if you remember. You know how to do the three equivalents? Remember the three equivalents? Remember, like for vanadium? Here's for vanadium. Ready? 1 mole of vanadium equals 6. Remember how to do that? You just had a quiz on it.
Yeah.
6.02 times 10 to the what?
23rd.
A mole of anything is 6.02 times 10 to the 23rd. Now, what's the smallest piece of an element? An atom, isn't it? So that's why I put atoms after this of vanadium. Now, equals how many grams? Look at, can you find vanadium? It's V. What do you have there?
I don't know.
See that decimal number above the V? Does that look like 50.9 to you? Let's put that down. 50.9 grams of vanadium. Now, this right here, these are equivalents, okay? Now, they're going to help me. They're going to help me solve this problem. So, what label do you want to get rid of? What label is right here? Grams of vanadium, right there. And I told you you have to get into the mole world, don't you? So we're going to change it into moles of vanadium. Now, watch what happens here. Ready? Find the number that goes with grams of vanadium. See it? 50.9. And what number goes with moles of vanadium? 1. Now, you just take your calculator, you take this number, divide it by that number, and just make sure you have 3 sig figs, okay?
Yeah.
Now, do you know how to do the oxygen mole thing? Okay, there you go. All right, are we ready? Oh. Okay. Yeah, okay. When you get back, I want you to sit with somebody, Zach. Okay?
That ring,
Looks exactly like it.
what did it look like?
What now?
The ring that you found, what did it look like?
Oh, I already found the owner, but they described it exactly, and it had like a silver intertwined thing with a green stone in it, and all right, over there. Now, all I want you to do is find the moles, okay? Have you gotten the moles yet? Okay. You guys are interesting. All right, let's stop. Everybody, let's stop for a minute. Now, it's not Thursday. It's not time for the test for sure. But without a doubt, you've got to be much faster than this by next Thursday. You get that? Like if I ask you to change grams into moles, that should be a no-brainer. Okay? Now, look right here. This problem was hard, not because of factor label, because of the first part. This is how many grams of vanadium and oxygen combined. This is how many grams of vanadium. If I subtract, it gives me grams of oxygen. So I'm going to use grams of oxygen, and I'm going to use grams of vanadium down here. Did everybody do that? Did everybody this far? Now, watch. What are the three equivalents for vanadium? 1 mole of vanadium is 6.02 times 10 to the 23rd atoms of vanadium equals, look on the periodic table, 50.9 grams of vanadium. Did everybody get that far? Now, factor label is supposed to help you think. You get it? Get rid of grams of vanadium by putting grams of vanadium down here. And I said get into the mole world. If you get into the mole world, you'll be able to find formulas. So I'm going to change it to moles. Now, when I say 3 sig figs, these zeros don't count. That's only the first sig fig, second sig fig. Everybody get it? The author went all the way to 4. I'm okay with that, but don't go down below 3. You get that? You can have 3. You'll still get the same answer with 3. They did 4. And I just got done telling you that this is where I would have gotten stuck if I were your age. Because I'm looking at some ugly numbers, and you forgot what your goal was. Your goal was to find the empirical formula. And that's the lowest whole number ratio. These are not whole numbers. And what's the math trick that's going to help me out? What now? No, not multiply.
Oh, yeah.
Divide by the what? The smaller one, right? And which one of these is smaller? Let's see, 0.006 or 0.001? Which one's smaller? 0.001, isn't it? So I divide this one by the smaller, and I divide this one by the smaller, and now the ugly numbers should start looking a little nicer. I'll bet you get 1 here, don't you? Now, I don't know, what is this one? What does it come out to be? 2.5? Man, that's much nicer looking, isn't it? Now, we're almost there. Empirical formula is the lowest whole number ratio, isn't it? Whole number. What do we have to do to this number to make it a whole number? 2.5, what? Times 2 equals what? 5. If you multiply that times 2, you're going to multiply that times 2. I'm done.
Mr. Feeney?
Okay, just a minute. Hello. Next period. Okay. Bye. All right, where's they at? All right, so I'm done. Watch. My analysis says in this compound for every what? for every what? 5 moles of vanadium, it'll combine with how many? 2 moles of oxygen. I did it. I found the name, I found this compound. Now, I happen to have, I believe I do have $1. I do. I will give $1 to the first person to give me the name of this compound. Oh, raise your hand, yes. Oh.
In the book it says there's 2 vanadiums and 5 oxygen.
Oh, I'm sorry. What? Wait a minute. Did I mix my numbers up?
Yeah, I think you just put the numbers in different elements.
Wait a minute. It is V2O5. What happened here? Did I switch the numbers? Okay, just a minute. Hang on.